Today we're going to be talking about one of the most useful things, something that again you're going to be using in many of your other math classes here. Right triangle trigonometry. Today I'm just going to introduce the sine, cosine, and tangent ratios. And what this has to do with is this has to do with a right triangle. So when you're looking at a right triangle and you're talking about some angle, and this angle, I typically use the Greek letter theta. You're just talking about some angle. Theta is just kind of a typical variable for an angle. So that's theta. When you're talking about that angle in a right triangle, the hypotenuse is always the side opposite the right angle. Now, in terms of this angle theta, that is the opposite side of angle theta, and this side here is what we call the adjacent side. So when we're talking about the sine, cosine, and tangent ratios, it involves the opposite, the adjacent, and the hypotenuse. So the sine, cosine, and tangent. These are the long form words for sine, cosine, and tangent. And there's an abbreviation. I'll talk about what this abbreviation means in a minute. But the sine, that's not pronounced sin. I don't want to hear you saying sin. It's sine of theta. It's an abbreviation for the sine of theta is the opposite side. It's the ratio of the opposite side over the hypotenuse. The cosine, not cos, cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. And there's an abbreviation that we use. So, toa. The sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. So when I say SOHCAHTOA, it's just an abbreviation to help you remember your sine, cosine, and tangent ratios. And what these are talking about is these are talking about the ratios of the sides. It's going to help us solve for x and y when we don't have one of our typical triangles, and you're going to need your calculator for this. So I need to solve for x and y. We are given 20 degrees. We are given the hypotenuse. Let's solve for x first. In relation to the angle that we're given, in relation to the 20 degrees, x is the opposite, and we have the hypotenuse. So sine of 20 is going to be the opposite side over the hypotenuse. Now I need to solve for x, so I multiply both sides by 5. So now x is going to be 5 times the sine of 20. Now pull out your calculators. So we're looking for the 5 times the sine of 20 degrees. Make sure your calculator first is in the correct mode. Press the mode button. And mine is not in the correct mode. If you look at the third one down, it says radian. There's two types of ways we can measure angles, radians and degrees. You'll talk about radians next year. Make sure your calculator is in degree mode. This isn't going to affect any other calculations except for when you're doing trigonometry. So once it's in degree mode, degree is highlighted, you can quit. And now your sine, cosine, and tangent buttons are right here. I remember it was a very exciting day in my math classes when I finally got to use those sine, cosine, and tangent buttons. All you're going to do is type exactly 5 sine 20 into your calculator. So 5 times the sine of 20, it's already in degree mode. You could just press enter. And we're going to round it 2 decimal places, so it's 1.71. So this is equal, x is equal to 1.71. Now let's solve for y. Y in relation to the 20 degrees is the adjacent side. So adjacent over hypotenuse is cosine. Cosine of 20 is the adjacent side over the hypotenuse. Again, we're solving for y, so we multiply both sides by 5. Now it's just a matter of typing that in your calculator. So again, we're trying to find 5 times the cosine of 20 degrees. We're in degree mode. You don't have to change anything. So we're going to do 5 times the cosine of 20. We're going to round to 2 decimal places, so that's going to round us up to 4.7. So y is going to be 4.7. Our next example. We're given 72 degrees, and we're given the side adjacent. We need to find the hypotenuse, and we need to find the opposite side. So let's solve for x first. In terms of the angle that we're given, we have the adjacent, and if we're looking for x, that's the opposite. So the tangent of 72 is the opposite over the adjacent. That's our opposite over adjacent, the toe apart. So just as we did before, multiply both sides by 3. Again, you can't do this without a calculator. Three times the tangent of 72. So it's just as we had been doing all the other ones. 3 tangent 72. Press enter. 9.233. So x is going to be 9.233, but we're going to round to 2 decimal places so that we don't need that other 3. Just helps us to round. Now to find y. I'm given the adjacent, but I need to find the hypotenuse. Adjacent hypotenuse is cosine. So the cosine of 72 is the adjacent over the hypotenuse. Now that's a little different than we've seen before. So if I multiply both sides by y, I have y times the cosine of 72 equals 3. Divide by cosine of 72, because remember that's a number that we're finding. So then y is going to be equal to 3 divided by the cosine of 72. So now type that in your calculator. Again, we were looking for y to be 3 divided by the cosine of 72. So just type it in exactly as is. 3 divided by the cosine of 72, and you get 9.71. So that's how you're solving for sides and triangles. Sometimes you're also going to have to solve for angles. Finding the measure of each angle. So angle P and angle N. It doesn't matter which one you find first, but remember, you already have a right angle. So P and N have to add up to 90 degrees. Let's solve for angle P. So in terms of angle P is like that theta. I have the opposite and the adjacent. So opposite and adjacent is tangent. The tangent of angle P is the opposite over the adjacent. Now how I solve for an angle is what we call inverse trig. P is equal to the inverse tangent of 18 over 11. So how we type that in our calculator. Again, angle P was the inverse tangent of 18 divided by 11. Notice the inverse tangent is second tan. That brings up inverse tangent. That's how you solve for an angle. That does not mean 1 over tangent. Does not mean 1 over tangent. It means how I find the angle. Type in 18 divided by 11, close the parentheses, press enter. That gets me 58.57 in terms of degrees. So angle P is 58.57. The other angle N, since those angles are complementary, just do 90 minus that answer to get angle N. So 90 minus that answer, 31.43. So we now have our two angles. P was 58.57. Again, to get angle N, we did 90 minus that. And we got 31.43 degrees. Another example of this. We need to find angle E and angle U. Again, they add up to 90 degrees. Let's look at angle U. Angle U, I have the opposite side and the hypotenuse. Opposite and hypotenuse is sine. So the sine of angle U is equal to 19 over 28. So to get angle U, I have to do the inverse sine of 19 over 28. Again, to get U, we do the inverse sine of 19 over 28. So, second sine, that brings up the inverse sine function. 19 divided by 28. So angle U is 42.73. The other angle we were looking for is angle E. That's going to be 90 minus this answer. 90 minus that answer. 47.27. So U, again, was 42.73. Angle E was 90 minus that, which was 47.27. So there are your lesson questions. I just have you solving for certain things. Make sure you round to 2 decimal places when you're solving for these, and make sure they are submitted on time.